Okay, so this is where we had planned to put our remove. Okay, so we'll take the value and we will remove the value here, right? So let's put calling header. Okay, so let's put header at the head, and we will traverse. It's like traversing and searching for the data and deleting it.
Yeah. Okay.
Okay, so now if it is head is none, right? If this is not none, then we have to do it. If this is none, then we don't have to do anything, right? So
Yeah.
let's say if uh if copy the same stuff. So I'm going to say if header. Uh, if header is none, then return. We'll have something like this. Do nothing, right? Return. Okay. Now, if header is not none. If header is not none, correct?
Yeah.
Then now if the first key itself has the key, right? So if head I'm just thinking, should we keep in a loop and let's see. Yeah, I was thinking if I have to put in a loop and then do it, but let's see. So if header is not none, and if header dot value, okay, is your value, okay, the value that we want to remove.
Yeah.
Okay, then we simply remove it, right?
Yeah.
So we will say
Drop or not drop. So that's not this.
we can you can you can simply set it to none. Okay, so but before we set it to none, we have
We have
to
to change the pointers, right?
change the pointer exactly.
Yeah.
Okay, so I'll say self dot head equal to header dot next node, right? And now I'm going to say header equal to none, right? Okay, and so this is how you will set header to none, right? And mm, instead, okay, so this is how. So I was thinking, okay, here itself we'll put a while. While header is not none. Okay. While header is not none. Okay. While header is not null, and if header dot value, okay, then we say pref now see, okay. Okay. Mm. Now, okay, so this may not be a good idea here because see, if we are a first header, right, then you don't have anything for previous link, right?
Mhm.
So we will handle it first header separately, and we'll have next header separately. Because first header and the rest of the headers are different. First header will not have anything previous, but next headers will have a previous header, right? First header will not have a previous linked list, previous list. You understood? See, there are three conditions, isn't it?
Mhm.
First, middle, and the last. So first one, we will not have the previous, it will not be linked to the previous one. Okay, it will only be linked to the next. So next we are handling, the way we are handling next is fine. But if it is not first one, we also have to handle, the previous value, right? So, so here I'm going to say previous, okay, equal to header, previous equal to header, and then header equal to header dot previous equal to header, and header equal to header dot next node. Okay,
Mhm.
header equal to next node. No, header equal to next node will be if it is not this. So we'll put it here. And if header equal to value, okay, this should be the thing. Let's see this, okay? I'm getting a little confused. Let's try this and see.
Okay.
So remove, right? R capital. So I'll say list dot remove 55, and we'll print the list here. Okay, so now
Mhm.
when you run it, 55. Okay, so we'll try to remove February from the list and see. So February should go. 55 was not there, it's fine.
Mhm.
Okay, none type object has no attribute next node. Okay, so header equal to none, right? And then self dot
So I'm not
head.
really sure what's happening. So
Okay,
I'm
so
just checking it.
let's do on paint first, and then we'll come back here.
No, I know what's happening. Like on the like, we're
No, no,
basically
no, no, no.
progressing.
We'll first do it, and then we will
Okay.
see where we are going wrong.
Okay.
Okay. So let's say you have okay. Now we're talking about okay. So if this is the first key itself, okay, then we are resetting header to here directly. There is nothing called previous, right? It's fine. But if you have to delete the okay, so we directly say here. So if I run this again, okay, if I go to the program, And this time I'll try to delete the first element, December, let's say. December is our first element, right?
Mm-hmm.
So I'll try to delete December, and it worked fine. Okay, December is gone. So work first, it is very simple. We are resetting it to null. Now, when we are talking about something in between, okay, let's say I have to remove this. So what we have to do is we have to reset this key to this,
Okay.
correct?
Yeah.
So that this is pointing here, and this one we can then reset to none.
Yeah.
So we need to break this link. We need to break this link, right? And then reset this link here. So we need to break two link. Which one? The current is set to none. Anyway, we'll break it. But the previous dot next should be header dot next. Previous dot next should be header dot next. I think this is what we are missing here.
Yeah.
Okay. So before we set it to none, okay. So we are saying, okay, while header is not none, this is fine. If header equal to key, okay, then let's do what? If this is equal to key, we will break it. That means we have reached the point where we don't have to iterate now. We don't have to traverse through the list. Okay. Now, so this one we will remove from here. But if it is not the, if you have not, if you have not reached to the exact node which needs to be removed, you have to follow these steps. Previous equal to header, and your header equal to next node. So this is for traversing, moving ahead.
Okay.
Okay. Now what we'll do is here outside while we will say previous dot next equal to header dot next node, right? We're saying next node. So previous dot next node equal to header dot next node. Correct? Done. And then we will say header equal to none. That's it. Simple two-step only, right? If we have reached to the point which needs to be removed, we are saying previous dot next node should be header dot next node and set header to none.
Okay.
Okay, that's it. And now we can run it. So if well, December is not getting it. None object has no attribute. Next node. Which line is it? 67. Okay. Before this, since we have reset the head, right, we have to check if header equal to none, because we have reset header. Now, if you have reset header, header will not have, okay, header will not have next value now.
Yeah.
So this is when first value is header, I mean, first value is the key to remove. Okay, so now when you run it, December is gone. Now instead of December, let's remove February. Okay, so here removing first value, and I'm going to say here list dot remove, let's say March. We try to remove March, something which is in between. And then we will say print traverse list. March is gone. Okay, so we are taking care of being first or, okay, so if header is done, return this is done. Now if header is not none, you move till you get the header. Okay, here to keep moving till you get the header. And now if previous equal to header, this is the iteration part. Now, if you have found it, if your header value is same as the value, okay, then you break it and we'll come out of the loop where we will perform this. Yeah. Okay. So we're checking again if header is none, then don't do anything. Otherwise, previous node equal to next node and header equal to none. In fact, we should do header delete header. I mean, just to delete it header, but okay, we can set it to none. That means anyway, that is removed from the list.
Can we go like step by step on so like
Yes.
we go
Yes.
up on?
Yes.
So first for remove, obviously header is equal to self.head. We check this, we starting of the linked list, we set it to head.
Correct.
After that, if header is none, we do nothing.
Header is none
Because
means
nothing's
what?
in the, that
Yeah,
means there's
list is
nothing in the
blank.
linked list.
Linked list is blank.
Okay. And if header is not none, means there's something in the linked list.
Yes.
We say header dot value is equal to value.
Yes, that means it is the first node.
Sir, isn't this repeating what the previous if is doing? If header is not none, and if header
Header
dot
is
value
none
is
we are
equal to
doing, no?
value. No, like line 58 and 59.
Header is not none, okay,
And header
and
dot
header
value
is
equal to
value.
value.
Value you are checking, no, it is not none. That means it is not the, it's not blank.
That's
Right?
what we're doing in 58 also, no?
You're doing in 58. Okay. No, I didn't get 58.
No, I'm saying like, isn't 58 and 59 doing the same thing?
No, here checking the value, right? Here checking the header is there or not. In fact, you could remove the first if here.
Okay.
Okay. See, here we are saying if it is not none, then what to do? Then you check for value. If header is none means it's not there, right?
If header is not none, means there's some value in the header, right?
No. This is the object. Object itself is not there.
Okay.
If object is deleted, object, and this is the value in the object is there, then if value matches to what value we are providing.
Okay.
Okay, this is the value of the object, and this is the object itself, right?
Yeah.
So object is none means object is not there.
Okay. So then we're checking in 59, we're checking if the value that we want to delete is the same as the value in the current node that we're in. And then self.head is equal to header dot next node is changing the pointer to the next node.
Okay. Now see, that means you found the node that needs to be removed. Correct?
Yeah.
Okay, first node in the list to be removed. Now, if it is first node, it's very simple, right? First node, okay, you simply so the header what we have, you move it to the next one. So header node will go to the next one, and this one you remove it. So simple, self.head equal to header dot next node. So the self.head is going to the next node, and this node you make it none. You don't have to break any connection here.
This is only for removing the first
node. Yes.
Node.
Okay. Because first node you don't have to add the link. You just delete the link. That's all. Okay. Rest everything will be in same order. You don't have to make any new link. You just have to cut the link. Okay. So this is what we are doing. Okay. We are saying the head should go to the next one, and then this one you are making it none.
Okay.
If it is not first one, then you have to iterate through this.
Yeah.
So while header is not none, so forget about this for a minute.
Okay.
While header is not none, then previous equal to header equal to header dot next. So you are having control to two nodes. One, the previous node and the current node. So previous equal to
what
header.
Is the current so the previous node is being marked as header?
So where you are standing now is marked as previous. Where you are standing now, header is where you are standing, right?
Yeah.
So where you are standing now is marked as previous.
Okay.
And then you move to the next node. Header equal to header dot next node.
Okay.
So you move to the next node. So that means every time you have access to two nodes, previous node and the current node. Current node is header, previous node is previous.
Yeah.
Correct? So you're saying previous equal to header and header equal to next node. So so that you have pointers, you have handles to 2 nodes at any given point of time.
Okay.
And again, you're checking header dot value. So that means the next value that you have moved to, that value you are checking, not the previous one. And the one where you're standing now, there you are checking. And if that is what has the value, we will break and will perform delete next. But for now, in this while, you are only trying to figure out the previous and the header value. Header is where you are. Previous is where, that's the previous node. Because the previous node should point to the header's next node when you are deleting header.
Okay.
Okay. So end of the loop, if the value is there, if value has a match, then you will have access to previous and header 2 nodes. If value is not matched and you reach to the end where, that's why we say, okay, this is when this is last, okay, or say you have reached last node and still not found. Value not matched and still value not matched. Basically means that you have given something which is not in the list. Value is not in the list. So you kept going next, and finally the last node's next is going to be none.
Okay.
So your previous is at the last node and header is at the none.
Okay.
Okay. So simply it means no value matched. You can give a message here. Print value not found in the linked list. Okay. So now if I give something like, say, March 1, and when I run it, okay, value not found in the linked list.
There are a question.
Yes.
When, like in coding questions, they won't tell us what to use. They'll just give the question and tell us to solve it. When do we know when to use linked list? How do we know when to use linked list?
Correct. Now, see, linked list generally is used when you have a large data, okay? And when you have large data, then it's not possible for, not possible for your lists to allocate continuous spaces. Okay. So if you're talking about interview, they'll tell you, okay, that implement linked list, because obviously if you use list, it becomes easy for you. Okay. But generally, okay, when you don't know exactly how many elements are there, and elements will keep on growing. Okay. So then it becomes, then you use linked list.
Okay.
Okay. When it keeps growing. So after, see, we create a list now and you keep on adding list. Now it is not possible to have a continuous allocation of memory. Then linked list is very useful.
Okay.
Okay. So you are constantly editing, you're removing, adding, adding. It will have a pressure on the memory. Okay. So if you do linked list, there's no pressure on the memory. It's like this. So if you have to store everything on you have to put everything on your table, and people keep giving you, oh, put this on the table, put this on the table, remove it from the table, put it on the table, right? You'll be busy, right? You have to put everything. Now, if they say put it anywhere in the home, then it is much easier to handle, right? So that way, because in list and in array, array is also a list kind of, right? So you have a contiguous. Contiguous means, at same memory location.
Okay.
So if it is memory intensive operation, it is better you use linked list. Okay. So yes. Next, what do we do? Okay. So So we'll stop here for today.
Okay,
Okay.
sir. What's the next stop?